It is January 22nd, 2020, and I'm going to come at you with a video here. Now, I'm going to show you some space weather conditions first, okay, just to kind of set a base of what we're going to talk about. I'm going to show you some CMEs that have been happening that hardly anybody else is even talking about. Scott showed one yesterday because it lit up our object, and I'll show you some stuff there. There was another one today that blew off the other side. Luckily, neither one of them were coming at us. And I'll show them to you here in just a few minutes. But I'll give you an update on the Schumann. There's some things there I want to talk about again. And we're taking some hits on our magnetosphere, you know. This solar wind level right here, 362, that is very, very normal and minimal. I mean, it's just mundane. It's like ambient conditions. That's like perfect wind speed, okay? But yet our magnetosphere is taking hits. And the reason why is because we were low. We were at extended periods of time of low solar wind speed, which is not good, okay? Because it causes our geomagnetic activity levels to drop. Now, we want to be in the middle, and I hate to use like a Star Wars term here, but yes, we need to find the balance in the force. Okay, that's what we need to. That's what we need here. All right, we don't need to be high. We don't need to be low. We need to be in the middle. Low lets in cosmic rays. High means we're getting high levels of charged particles just bombarding our planet, and it can cause lots of different things. Electrical outages, earthquakes most definitely go up. Okay, so yeah, as you can see, we were low and we kind of spiked up there a little bit because we did get a small solar storm that we were expecting to see. But the solar storm is, you know, giving us wind speeds of that. That is not high at all. And more evidence of that is the ACE here. Okay, this is the ACE data. Now the wind speed is in yellow and the orange is the density. All right, you guys can see that that's just very, very just straight line, very normal. I mean, there's just absolutely nothing strange there at all. Maybe with the exception of this little swoosh thing. I mean, it looks like it got variable there a little bit, high, low, but it's not much, is what I'm trying to say. And this, you know, it only goes up to 400 kilometers per second here anyway on this graph right here at the moment. So nothing's over 400. We did see some over 400, and I can show you that later. But we were taking some hits. Now, this is the Enlow model. Now, again, guys, this is the one I show you guys when I'm talking about. This is a forecast model along with a historic model. So right now, we're probably about right here as far as time goes. Okay? That's where we're at in time. Now, it's trying to predict what's going to happen out in front of us 5 days. All right, and I've shown you guys this a bunch. This thing changes on just like every hour almost, it seems like. You know, it's to the point where I almost don't even trust what this thing forecasts anymore. It is a good thing to look at just to get kind of like a basic understanding of what could be happening. And sometimes this thing is right, but at least my experience, you might be able to go out 1 or 2 days, but you try to say, hey, yeah, that's what's going to happen in 5 days. Every time this thing is wrong. So I don't even hold much stock into it anymore, except for the fact that, you know, yes, we can look what happened behind us 2 days, because that is actually what did happen. And I do trust it for about 2 days out. Okay. It is right most of the time there. Now, it's predicting an uptick in the density there, and I would assume that that's probably from one of those little solar storms that got fired off our way. Now, we look at the spiral graphs. Okay, that's a top-down view. That's a side view. All right. Now, you can see, I mean, it's just telling you the same thing. It's just giving it to you in a visual that this graph over here is telling you. Now, the green line is the conditions at Earth. Now, if you notice, look here. Stereo A is the red line. That's the conditions or the environment around Stereo A. Where is Stereo A? Here's Earth. This is Stereo A. It's looking at the sun. So, what does that mean? Because the conditions at Stereo A, why do we even care? Well, there's a couple reasons why we care. The first reason is because sometimes we start seeing anomalies on these cameras that are on Stereo A. And if it's getting hit with a solar storm, it doesn't have a magnetic field like the Earth does to protect it. So we have to understand that if it's going to get hit with a solar storm, sometimes it'll give us false readings. Okay, that's one reason. The other reason is if we know the CME or solar storm or flare went that direction, we know that it's not coming at us. That's the other reason there. So that's why they keep track of this stuff. There's other reasons they do too, but and then down here is the speed, solar wind speed. Now you're going to notice when you see this, it seems as though right in the track where the Earth is at, it seems to stay pretty consistently like in the middle. I'm not sure if this is a model flaw because I don't see why that should be like that all the time. But it seems to be. Now you can see conditions change. Yes, it does show us getting hit sometimes, but I wanted to show that to you. Now, this right here is also really what I want to show you. This is the electron flux. Okay, you can definitely see we had an influx of electrons for an extended period of time. Now, if you go look at the KP, like what I just showed you up there, the geomagnetic activity level, this is almost directly coinciding with the uptick. Okay, and that's pretty much what we usually see. Okay, it's shooting charged particles at us, the sun is. And so when we get those particles, that's what happens. And it shows right here. It's a very good explanation and very good visual of what's going on. Now this is the auroras. All right. It just tells you, gives you a baseline of what the aurora forecast is. Wherever you're at in the world, if you can, this is good for aurora photographers. And it's also a good tool to look at if we're expecting a solar wind stream, okay? Because the more charged particles that bounce up off our atmosphere up there, the bigger the auroras are. Sometimes they start creeping. When we get big geomagnetic storms, they'll creep down into mid-latitudes where we can actually see them down closer to the equator. But not all the way. I think that's happened like once or twice, maybe in recorded history. Don't quote me on that. I'm not for sure. But if we start seeing auroras down on the equator, guys, yeah, we probably wouldn't be having this conversation. That would be a major storm, and I would think that we would have electrical issues, satellites, the whole thing. But that's why we look at that stuff, and anybody that's an aurora photographer, we've all seen those beautiful pictures of the auroras. They're really neat, they're pretty. I enjoy looking at them. I don't show you guys a whole lot of those because most of those are copyrighted, because they take a lot of work to get sometimes. So, but I'm going to take you over here and show you the CMEs real quick. Okay, guys, I got you over here at Seeds. This is where I usually take you guys to show you the CMEs because it gives us a really good capture when this tool is updating. Now, I have to say straight off the bat, and this is the one I showed you guys the other day. This is back on the 19th. That this is a very strange acting CME. Okay, it didn't act normal whatsoever. Okay, it's moving. Seems to be moving kind of slow. If you look, you can see. Watch as it starts back over. You'll see like a little hook right here that appears and then it goes. Well, what happened was our object was there. Okay, that's what caused the CME. Now, looking at this, the Earth is here. Okay, we're looking at the sun, right? That's where the satellite sits out about 1 million miles closer to the sun than what we are. It sits right out in front of us. So looking at this, it looks like this thing blew right off the side. Well, it actually didn't. And I explained this in my last video. It actually blew this way. Okay? And the way to check that, and I'm going to show you guys how to do that again, is to go to Stereo A. This is a good way to do it. You go to the 19th. I'm showing you guys this for a reason so you guys can do this yourself if you guys see this stuff. Okay, obviously that's that same CME. But what's the difference? Well, the difference is the position, the angle that we're looking at it from. Okay, Stereo A is here, but the Earth is here, and SDO is right there what we just looked from. Well, SOHO is right there. Okay, but what we're looking at from right now is Stereo A. It's here, and it's always looking at the sun. So remember what I just showed you guys? It looked like it was blowing way off to the left. Well, looking at this, it shows that it's actually blowing off towards the backside of the sun. Now let me correct something here real quick. Okay, because that wasn't exactly correct. That's the Earth. Stereo A isn't directly to the side, 90 degrees. It's actually about right here. So that's why we catch this thing, and that's why it kind of looks like it's going directly off to the side. But if you take in consideration both of the two different tools and locations I just showed you guys, what's happening is it's blowing off at that angle I showed you. Okay? So the Earth is here, and it's actually kind of blowing off that direction is what's going on. All right? Now, let me show you the new CME. Okay, that just happened today. I actually sent Scott something early this morning. I seen it start. Now, I didn't see it end until just a few minutes ago. This one actually was kind of strange too, and it was missing data, guys, in the middle of it. And I went back and checked, and they actually added the data back in. This doesn't look very, very, it doesn't look horrible, okay? But I'm going to show you something, okay? It's right there whenever you see these bright flashes, okay? Now, again, guys, we're looking, this is the Earth, and here's the SOHO. It's looking, so it looks like it's going off to the right, right? Like the other one looked like it was going this way. Well, let's go look at stereo A on this day. Okay, what's happening? That's that same CME, but it's not going to the right, is it? See what it's doing? Okay, it's firing off towards the back too. So, let's go back up here to SOHO and I'll show you. So the Earth is here, and the CME looks like it's blowing off to the left, but it's actually blowing that way. Okay, so neither one of these are coming at us. Now, I showed you guys all that just so you guys could understand that's how we kind of deem the direction that things are going. We can kind of get a better angle if we got two different perspective points. Okay, now what I'm going to show you here, I'm going to show you some captures that Scott made. Okay, so this is the capture from SOHO, one over at Seeds. Okay, this is that CME back on the 19th, the date there. What Scott's got this new software he's been messing with and trying, just doing different things. Well, he was able to take this and put the two-dimensional model I was showing you and put it into a three-dimensional model. And this is what he came up with. All right, there's our object, guys. Okay. I've not seen too many more clearer pictures of what we're talking about. That is one of the most defined looking capture that I've seen of our object. Now, what's strange about this, guys, is it showed up exactly when it was supposed to. The sun did exactly what we've been telling you guys it's been doing when this object comes around twice a month, usually. Plus, I'm going to take you and show you something else, okay? But before we do that, I'm going to take you over here to this capture. Now, this was on the 21st. Now, I'm not sure if anybody's done any videos on this, but I'm going to show you guys something here, okay? This is not nothing to worry about. This is just simply a camera anomaly, all right? I didn't go back and look, but I know that I can go back on multiple days, and we're going to see this exact shape, okay? And when we see this exact shape, if it's repeatable like that, most of the time it is nothing that is anything else but a camera anomaly. All right, now this is one of the more odd ones that I've seen as far as the details in it. It looks as though that, it kind of has a darkened area in the middle, But what we have to keep in mind here, guys, is that this satellite's looking at the sun at about 92 million miles away from it. Okay? A lot of things can happen in 92 million miles. What I'm trying to say here is that we have no idea what is going on between the satellite and the sun, so we cannot tell you the position of this anomaly if it's actually even anything to even be paying attention to. Okay? Because if it's closer to the satellite, it's going to look bigger. If it's closer to the sun, it's going to look smaller. Now, to give you guys a little bit of a perspective here, if this was an actual real thing, let's just take in consideration, we're just going to say, hey, this is real, right? And we think it's out by the sun. Well, this is the size of the sun. Do you not think that if something is that bright, that size, got that close to the sun, that we would be having this conversation right now? I don't think we would. Okay? What I'm saying is that if something zipped by the sun that fast, that large, because it's as big as the sun, it would have to be, if you look at it, okay? It would be almost the same width as the sun, and it would be traveling that way, or the other way, or whatever. So what I'm trying to say, guys, is I can go find you another camera anomaly, and I might do that later on, that it shows you the exact shape here. And the telltale giveaway is that it actually will bend in towards the occulter. Okay? What this is, guys, is this is the internal parts of the camera getting illuminated by a flash. A bright flash. It caught some light from somewhere, or it could be charged particles. In other words, this camera had an issue. That's just simply what this is. And it happens a lot. Okay? And when it happens the next time, I'll show it to you guys, and I'll compare the two pictures, and I'll show you guys that this is definitely absolutely nothing to even be talking about, really. So I just wanted to show you guys that in case somebody is make a video or something about this, and they, I ain't saying that they're trying to do anything wrong. All I'm saying is that they could be incorrect. Okay? So when you see that, just kind of look at it that way. Okay? All right, guys, this is the Schumann. Okay. This is the most up-to-date capture we got. Now, this doesn't look too impressive, right? But to me, it does look a little bit strange. And the reason being is that you see these spikes. You notice how bright white that they are? That means that was a very intense signature there. Okay? And something else, guys, like I said before, the stripes, they're happening. Okay? They don't line up with one another. This is why I'm having an issue with thinking that it's a tool flaw, because they don't, and at some level, they're not even perfectly horizontal. Sometimes they kind of even bend a little bit. So I do think that these may be something that might be a vibration thing there, a frequency thing there that's happening to cause that. In other words, I don't think it's fake. I think maybe it could, I guess it could possibly be a tool flaw, but at this point, I truly don't think that. I really think that we have a vibrational or frequency happening that's causing this pattern. Not to mention, there's our dashed line, our signature that I guess we're calling it a code or a signature, whatever we want to call it. And once again, guys, if you notice, most of the activity is happening from that line downward. And I mean downward in frequency. If you guys go up on this graph, you're actually lowering the frequency. Okay? And we don't have, outside of the spikes, we don't see much activity. Okay? So yeah, I just wanted to bring that to you, give you guys an update on that. There's not no large spikes, but these are intense. They seem to be, they're running about an hour and a half long duration, but they are intense. I don't know how high they go. 40 hertz is as far as this graph will show you. There's other graphs we could go look at and see, but just know that it's spiking, and at least we don't have no blackouts here like we had been seeing. Alright guys, this is the Magnetosphere. This is one I show you guys all the time. I did want to give you an update on this because I just want you guys to see it. And we're going to take a look at some solar wind speed and all that kind of a thing. So what we'll do is we'll look at this one first. This is the solar wind speed, okay? And where to get the solar wind speed is right there. Alright? Now, you're going to see it. It's going to go up to like 700-800, I think, which is decent speed, okay? We would expect to see some hits at that speed. Alright? It got up to like 700, it looked like 750, maybe 800. We'll convert that to miles per hour here in a minute. But I want you guys to see what actually happens. Okay? Now, I will say this. Again, these are kind of strange signatures that's happening here. I've been noticing some stuff inside of our bow shock, okay, right around our planet even, that is doing strange things. I'm seeing stuff move in odd directions, and I'll show those to you here in a second. But as you can see, we get hit, right? And you see what happens. Boom. Okay? What happens is, guys, when we get hit, we get compressed. And then when we get compressed, we have rapid expansion because we're pushing back. And when we finally win that battle, it expands way out. So it's called rapid expansion. It happens very fast, and it doesn't last very long, just so you guys know that. Now, as you can see, when we get hit out here, I've been noticing this. Okay, I'm going to stop it right here. You see this right there? That particular direction of density right there, you can even see that where that light blue is, the direction of the wind, which is what these arrows are showing you, is different, and it's following that. Now, why is that? Well, because the solar wind actually grabs some of the particles, okay, and it shoots it on off. It kind of washes us, all right? So when that solar wind hits us, yes, we might see a big dense spike, but then it will actually level back out, and we'll see a lower dense material. It grabs some of the particles, and it gets it out of there, so the density of these charged particles goes down when we get these winds. Okay, that's why when we look on the graph, when we get high wind speeds, a lot of times we're seeing low density. Okay, and then vice versa, when we're seeing high dense, usually the wind speed's slower. All right, but I did want to show you that because that is something I've been noticing. It doesn't seem to be in any other place, but it does seem to be repeating. I'm not sure what's causing that, but, you know, that is happening. So, and if you look around our planet, you can see, you know, the light blue around the front here isn't quite normal. Yeah. So, I'll just say that right now. Yeah. Not really a whole bunch more to say about that, but I do want to show you this one. Okay, this is the one where it's going to show the direction of everything. Let me see if I can't find it. Now, again, this is a good one to see how we kind of pushed out there. Now, there's one of the directional things. What I want you guys to look at is right in here. I'm going to zoom in a little bit, and we're going to take a look real quick right there. You're going to see lighter, different dense material. And it's going to start here, and it's actually going to get washed off that way, the wrong direction. Okay? It doesn't have, you gotta really pay attention. Okay, I'm going forward now. There it starts, and you see how it gets washed out, like almost parallel or horizontal. Okay, it's almost going this way, which shouldn't really be happening. Because sometimes when we get hit with solar wind, yes, we'll get what we call the rebound effect. It'll hit our bow shock, and it'll get sucked in like this. And that's how sometimes we get that backside pressure. That does happen sometimes, okay? So if we watch this, there's stuff happening on the inside here. We're seeing contortions too. You see that right there? Nothing's happening up here, so that's directional, all right? That's why we're seeing that. There it is again. See, watch. We're going to get hit here, and you're going to see this material get pushed off that way. Watch. Let's back it up. There's the hit right there. Now watch what happens. See how I get pushed off that direction? Back it up, hit, and it pushes off that direction. It's real fast, and it's real light, but it is happening. So that's telling me that that's coming from that direction. That ain't coming from the sun. All right? It's coming from something else. You know, there's a whole lot of theories on what that is. It could be anything. It could be cosmic rays even. It could be our object out there, its magnetic field interacting with what's going on. All that stuff is possible, guys. Okay? But yeah, I wanted to show you guys that, kind of give you guys a rundown on that. I think I will end the video here. The wind speed itself, guys, I show you it was about 800 kilometers per second. I think that computes to a little bit over 1 million miles per hour. It might be a little bit more than that, like 1.5 million miles per hour. So just kind of keep that in mind. Is that out of the ordinary? No, that's really not that high. And again, don't freak out every time you see a signature like that, like it just showed here. Okay, boom. You see that? We took a hit. Yeah, it's definitely a hit. but we recovered. We're fine. You know, we're having this conversation. We're all good, right? Okay. So, yeah, but we do need to pay attention when that stuff is actually happening. Also, I want to mention the coronavirus that's going on. I'm going to leave a link to Scott's video, his new channel, Project Disclosure. He did an article on that today, guys. This is not good, okay? You guys know I don't say that very often, that it's not good type of situation. But this is one of those situations I'm going to use that word because it's not good. This stuff it's bad, okay? Just pay attention. Just be aware. Wash your hands often. If you go outside anywhere, when you come back in, especially protect your kids, okay? There's not a whole lot we can do about, anything else, but the main thing we can do, and just about any medical professional will tell you this, the best defense against anything like this is frequent washing of the hands, okay? Especially when we're talking about babies and kids and all that kind of a thing. We know how they are. They'll stick their finger in their nose and anything else. And, light sockets, everything, anyway. But that is the truth. So take that serious, okay, guys? If I've said anything in this video at all that I want you guys to take from this, take that serious because that will directly affect you immediately. So just keep that in mind. I'll leave a link to Scott's video on that. And again, guys, go check out that new that picture I just showed you guys of the 3D model he put up of our object. I mean, and at this point, guys, like I said before, we've said, hey, this object's going to be here, CME is going to happen, and it does. This is just another one of those times. So I guess I'll just end it there, guys. God bless. Shoe saves, and you can drink this Kool-Aid.